For Learning Target 9A, we're going to use this first data model for questions 1 through 7, not 8. And we are given a table, a table that gives us the number of minutes students in a class studied for a test and the score that they got on their test. So the first thing we're asked to do is to try to draw a line of best fit. So again, if you're doing this with technology, you can get the actual line. If we're just doing this kind of eyeballing it, what we think is a possible line of best fit, we could just kind of take our ruler to think, okay, I want a line that has a positive slope because I could see as x increases, my y data is increasing, and I want about the same number of points below and above my line. And so I don't know. Then from there, we're just going to ballpark it. So this looks like it may be a good line. Yeah. So again, without using technology or doing it the very long way, we're just going to do our best guess at that line of fit. We're given the correlation coefficient of the model, which is 0.9099, and we are asked what that value means about the relationship between the time spent studying and the test scores. So remember, when we read a table, the first variable in our table is our independent variable, so I'm going to call that x. Our output is the next column, and that's our dependent variable y. So that's how I know that on my x-axis of this graph, this is time spent studying in minutes. And on the y-axis, that is the score on the Unit 9 or Chapter 9 test. So when we talk about this relationship, we know that R is positive. We know that anything above 0.7, between 0.7 and 1, we're going to say is strong. So we could say that there is a strong positive correlation, or you could also say association, between, and when we answer this, it's always between x and y. So just what are our variables? So between time spent studying and the Unit 9 or Chapter 9 test score. All right, so instead of saying a strong positive association or correlation between x and y, we want to substitute our actual variables for x and y to make our answer in context. All right, question 3. The equation for the regression line for this data is y hat equals 6.88 plus 0.90x. So what do x and y represent? Well, we already kind of addressed that. We said x is the amount of time spent studying, and to include units, we know that is measured in minutes. And y, or if we were to interpret this as y hat, we would just include the word predicted. So y hat would be our predicted Chapter 9 score. All right, so in question 4, we are asked to write a sentence to explain what the point 0, 6.88, so 0, 6.88 represents and means in context. And we know that's our y-intercept, 1, because this equation is in slope-intercept form, and 2, because the x value of the coordinate is 0. So to explain what this means in context, remember when x is 0, this is what we expect y to be. So just fill in, instead of saying x and y, fill in the actual name of the variables, and that's how we make this prediction in context. So when time spent studying, remember this is x, so when time spent studying is 0 minutes, our model predicts a Chapter 9 test score of 6.88. So not a very good outcome for students who didn't study for this test. And then in question 5, we're asked to write a sentence to explain what the slope means in context. So remember, we wrote in our takeaways that we could think of slope as a unit rate. As x increases by 1, the slope is how y changes. So as time spent studying increases by 1 minute, the predicted Chapter 9 test score increases by 0.90. And there's other ways to say that. You could say, like, for each additional minute studying, the Chapter 9 test score is predicted to increase by 0.90. All right, in question 6, we are asked to use the model, our equation for our linear regression model, to predict the test score for someone who studies for 2 hours. And we know 2 hours is 120 minutes. So remember, our time spent studying, that is what is on our, or that is our variable x. So I'm going to substitute 120 for x, and this is asking me to find what y hat would be, because we're trying to find the predicted test score, and that's our y hat. So we know y hat equals 6.88 plus 0.90, you don't have to write the 0 there, times 120, and we can use the calculator to help us out. We could either do that in 2 steps, or we could do it in 1, because the calculator knows the order of operations. So 6.88 plus 0.9 or 0.90 times 120. And we get, wow, 114.88. So we don't know if this, well, I guess we'll answer this in the next question. Okay, so in question 7, it asks if this prediction is reasonable, why or why not. And I don't know. I'll tell you why we're going to say no to this. But first of all, what we don't know is, are there any extra credit opportunities on this test? Or is it the kind of test where the maximum score you can get is 100? So what we do know, though, if we go back to our table, we just plugged in 120 for x. And if you look at the range of x values that we had considered initially when we collected our data, that went from 7 to 78. So I would argue that the number 120 is just too far away from that set of collected data. And in math, we call that extrapolation when we use our prediction line to predict something that's outside of the range of our collected data. So it's really for that second reason that I'm going to say, no, this is not reasonable, because x equals 120 minutes is outside of the collected data. And again, we said the real mathy word we use for this is called extrapolation. And you don't have to include that word in your response, just in case you were curious. Lastly, if you think about it, if we were to keep increasing x, eventually we could get to a test score of like 5,000. So really, that linear model is only good for a certain range of data for the prediction.